Okay, moving on to our last three, we're looking at our last section where we solved nonlinear systems of equations and inequalities. So 13 and 14, we have a couple of systems of nonlinear equations with two variables. And you can see here in 13, now that we've studied our conic sections, we've got an equation of a circle here in this first equation, x squared plus y squared equals 145. And it is in standard form, right? We've got the sum of those two squared terms, coefficients are both 1, equal to r squared. So you can see your center will be at the origin, radius will be the square root of 145. And then you got an equation of a line, x minus y equal 1. Now, what I want to do is find out, would these two equations intersect? Would they intersect graphically? Does it have a solution? Is it a consistent system? Can you find an ordered pair that satisfies both? Right, we're trying to solve the system of equation with two variables. So to do that, let's find it algebraically. I'm going to use the substitution method. So I'm going to solve this one with substitution. We have substitution and we have elimination that we've talked about. Now, I would use elimination if I had like terms in both equations, but I don't. Right, we have a linear equation with first degree variables, and we have a circle equation with second degree variables. So with that said, in the substitution method, right, it says pick an equation and solve for a variable. So I'm going to go ahead and take equation 2. So my first step is I'm going to solve equation 2. All right, I'm going to solve it for x. So pick an equation and solve for a variable. So if we're going to do that, right, we're going to add y over. So that would be x equal to, what, 1 plus y. So we add that y over to the right side. So as we solve for x, we get x equal 1 plus y. Now, here's where we substitute. So the substitution method says, now we've got an expression of y that represents x. So we're going to take that expression and substitute into the other equation. So that's where your substitution step comes from. So now we're going to substitute into equation 1. All right, so the one we did not solve for, the circle equation. So x squared would rewrite as 1 plus y squared plus y squared equal to 145. So now we got an equation we can work with. We got an equation with one variable, that variable being y. Now, what is 1 plus y squared? Let's go ahead and square it. Of course, 1 plus y squared is 1 plus y times 1 plus y. So as we were to square that, we distribute. 1 times 1 is 1. 1 times y is y. And now as we distribute the y through, y times 1 is y. Y times y is y squared. All right. So with that said, that's the square of y. Now we still got another plus y squared equal to 145. But we distributed as we combine like terms. So we got 1 plus 2y plus y squared equal 145, which means what? We got 2y squares. I'm going to go ahead and rewrite it in standard form. Plus 2y plus 1 equal 145. Now in solving a quadratic equation, so we're looking at a quadratic. So with a quadratic equation, we can set it equal to 0, try to factor it, and we can use the quadratic formula, we can create a square. So that's going to be our next step. Let's go ahead and set equal to 0. So we'll go ahead and subtract 145 over to the other side. So 2y squared plus 2y minus 144 equals 0. Right, setting it equal to 0. Right, getting that in the standard form. Now, what I'm going to go ahead and do, I want to simplify. All right, I'm going to go ahead and reduce it. I see a common factor of 2, so we make this a little easier to work with. I'm going to go ahead and divide a 2 out on both sides, just to make my equation a little easier to work with. So we have y squared plus y minus 72, right, as we divide a 2 out. And then I'm going to solve by factoring. Right, we know every quadratic has 2 linear factors. We can see this one with 72. We know 8 and 9 are our combinations. right? We would need a y plus 9 and a y minus 8 to make it happen, right? We got a inner product 9y, outer product negative 8y. They add up to 1y. If we were to distribute, combine, full out, right, we get y squared with y minus 72 back. So with that said, we've now got our factors in front of us. So that means we have our solutions, right? We can go use our zero factor property. Y plus 9 can equal 0, or y minus 8 can equal 0. So y equal negative 9, or y equal 8. All right, so now we got to go find x. So we got to go find x, and to find x, we're going to go back up. So we'll call our back substitution step. So we're going to go back up to the beginning. So let's do that. So y equal to negative 9. Well, remember, we've already got our equation, right? We want to know what x equals. So remember, x is equal to 1 plus y. So that implies x equal 1 plus negative 9, which means x is equal to 8. So when y is negative 9, what do we find for our value of x? Negative 8, right? So again, simplifying that down, 1 plus negative 9, that's a negative 8. Careful with your sign. So with that, we got an ordered pair of negative 8, negative 9. So there's a solution to the system. Now, what else happens? We also have y equal to 8. Right? What's x equal? So as we plug that in, we have x equal to 1 plus y, 1 plus 8, which is equal to 9. So that implies we have a solution of 9, 8, 2. And these are your two intersection points. So if you were to graph, right, so here's my solution set, right? These are the intersection points for the graph. So that'd be a way to check it if you wanted to, right? This is where the two graphs intersect each other. But there are solutions. So yeah, we got negative 8, negative 9, and we got 9, 8, right, for our ordered pairs in solving 13. So that's using the substitution method. Pick an equation, pick a variable, solve for it, right, and then substitute into the other equation so you can solve that one. So we're going to do a little review of quadratics. Now I want to review, in my next problem, I'm going to review the elimination method. So I'm going to use elimination on this next one. And I want you to look at this nonlinear system. We've got a hyperbola. We got 5x squared minus 5y squared equal 20. So that's a hyperbola that branches out right and left based off the x squared term being the positive term. And then we have an ellipse. This is an ellipse and a hyperbola, these two equations. So with that said, and using the elimination method, I'm going to try to eliminate a variable from the get-go. And the reason I want to do elimination is I already have like terms in both equations. So let's focus in on, for example, these y terms. So if I want to eliminate, I want to make coefficients opposites and add. Make coefficients of x or y opposites of each other, right, and add up. So let's do that. So with y squared, let's go ahead and make that second equation have a positive 5, so we can get a 5y squared and a negative 5y squared. So I'm going to do 5 times equation 2. So I'm going to leave my first equation alone. I'm not going to multiply it by anything. So I got 5x squared minus 5y squared equal to 20. And in my new equation, now that I'm multiplying by 5, 5 times 4 is 20, x squared, plus 5 times y squared is 5y squared, and 5 times 16 is 80. So there's my equation there, 5 times equation 2. Now I can add them up, right? And when I add these up, I'm going to get exactly what I'm looking for, right, which is eliminating the y term. So 5x squared plus 20x squared, they add up to 25x squared. These cancel, and this gives me 100. So I've got a resulting equation, right, with one variable. So now we need to solve that for x. So as we solve for x, we'll divide out a 25 on both sides. Right, and that would give me x squared equal to 4. And don't forget, we take the square root. Now it can be positive or negative with even roots. So it'll be plus or minus 2. 2 squared is 4, negative 2 squared is 4. So yeah, I've got x equal to 2 or negative 2. Now I've got to find y. So I've got to go back up, right, and substitute. So I've got to do my back substitution step. So let's do that together. So again, let's start with x. So if x equal 2, what does y equal? So remember, we can plug it into either of the original equations. So I'm going to plug it into my second equation. I know that 4x squared plus y squared equals 16. So that implies 4 times 2 squared plus y squared equals 16, which is 4 times 4, and that gives me 16. Right, and as we solve that for y, we subtract 16 over on both sides. Get y squared equal to 0. As I take the square root, there's no such thing as a negative value of 0. We get y equals 0. So when x equals 2, right, y equals 0. So here's our ordered pair that we found. We've got an ordered pair of 2, 0 as a solution. So there's one of my solutions to this problem, the ordered pair of 2, 0. Now we also have to look at x equal negative 2. So let's plug it in. So what happens with x equal negative 2? And I'll plug it in black. X equal negative 2, y equal what? So as we plug it into our equation, so 4x squared, 4 times negative 2 squared plus y squared equals 16. Well, that's 4 times what? 4. So as we simplify, we get 16 again, plus y squared equals 16. As we subtract 16 on both sides, right, we get 0. So if y squared equals 0, then y equals 0. So our other ordered pair would be negative 2, 0. So 2, 0, and negative 2, 0. So two solutions, and you graph them, plug them in, check them. Right, and you can always plug them into both equations to see if they work. So do your check step. So there are my solutions. Now that one worked easily with the elimination method. Now I could have used substitution. Be a lot harder on a problem like this one. Right, I could have picked an equation, solved x or y, and plugged it into the other. But again, like terms, use your elimination method. Go ahead and eliminate a variable out from the get-go. Make those coefficients opposites. Multiply by whatever you need to make them opposites of each other. And so we finish off our review. Our last problem is we're going to solve a system of inequalities by graphing the inequalities. All right, we're going to look at shading in our solution set. So with that said, our first step is we need to graph in the related equations. So we need to form what I call our boundaries. There are boundary equations. All right, so let's go ahead and take the first equation. We got x squared plus y squared equal to 16. So again, this is a circle, right? So you're looking at this equation. This one's already in standard form. So we're looking at a circle equation. We know the center point, right, is that ordered pair h and k. It's centered at the origin. We know r squared is 16. So r is equal to 4. So I can go ahead and graph in that boundary. So let's go ahead and start building in a graph of what we're looking at. So here at 0, 0, we're going to measure out 4 units. 0, 4. I'll go ahead and plot in that point. We'll go right 4 units. We'll plot into point 4, 0. We'll go down 4 units. We'll plot into point 0, negative 4. And we'll go left 4 units. Plot in negative 4, 0. So again, there's my radius. Radius is 4 units. Now, this is a less than equal to problem. So we're going to put in a solid, right, boundary. All right, solid line for the circles. We go ahead and circle it in. So with that said, we're going to have solutions fall on this circle because, again, that's when it equals, right, 16. Right, those are all ordered pairs that make it equal 16, but we've got to figure out when it's less than or equal to 16 with the circle. And then we got to graph in the other inequality, the other related equation. So as we look at our second inequality, the related equation is x plus y equal to 3. Well, I'm going to go ahead and solve that for y. Get it in slope-intercept form. It's a linear equation. So here y equal mx plus b, right? So our slope is -1. Our y-intercept is at 0, 3. So with our slope at -1, remember now that's rise over run. So that's down 1, right? Right 1. So I'm going to review slope. Slope definition. Rise over run. M equal rise divided by run. So let's go ahead and graph in this circle. So we have a y-intercept at 0, 3. So we'll go ahead and plot the point 0, 3. So here's that ordered pair, 0, 3 there on the y-axis. Now to find another point, I'm going to use a slope. So if I go a slope of -1, right, let's go ahead and, let's go ahead and erase this out so we can get a better picture, understand a radius. Right, but I'm going to go down 1 unit. That'd be at 0, 2. And I go right 1. That'll be at the ordered pair 1, 2. So I'm going to go ahead and plot the point 1, 2. Right, and I keep going down 1, right 1. Down 1 would be at 1, 1. Right? Right 1 would be at 2, 1. So we could keep moving, right? Or 3, 0, I should say. Right, so moving over there on that graph. But 1, 2. And I'm going to go ahead and plot in that point or that line. Now this is a dashed line. The reason it's a dashed line, make sure you dash it in, is we're not going to include any points on that line because we have a less than problem. It's not less than equal to. So solid lines, right, if we have equality, dashed in lines, dashed in boundaries, if we have no inequality, so just less than or greater than. So you can see the difference between the circle and the line as far as dashing in or making it solid with your boundary. But with that said, I've got a picture here of my graph. All right, now that's enough to go ahead and talk about where our solution set will fall. So now I'm going to pick a test point. So we got to find a point, right, that satisfies both. So let's go ahead and take a quick, easy point. So I'm going to pick the origin. So I'm going to use a test point here. Let's test it with the point 0, 0 right here. I'll use that point. All right, with that said, as we test it, we got to plug into both. So remember, we got x squared plus y squared must be less than or equal 16. Well, is that true? That'll be 0 squared plus 0 squared less than or equal 16. Well, that gives me 0 less than 16. That's true. So that's a solution to that inequality. We also have the inequality of x plus y less than 3. Well, does it satisfy that? That would be 0 plus 0 less than 3. Well, as we simplify, we get 0 less than what? 3, which is true. Right? 0 is less than 3. So it satisfies both. So yes, 0, 0 is a solution. Right. So that's a solution to my system. So that means we need to shade in everything, including 0, 0. So everything below that line, not on it, and anything on the circle, right? We got to include these points also. Now we don't want to go outside of the circle, because if you go outside the circle, you're no longer going to satisfy the inequality, right, of x squared plus y squared less than or equal to 16. So keep that in mind, right? Make sure you remember you got to satisfy both. For example, if you plugged in 0, -5, right? When you plug that in, you get 25. 25 is greater than 16. It doesn't work. So again, unsatisfied. So shading it in, we'll highlight in blue. There are all our solutions. So again, shading in the solution set. So picking that test point must work both. If it didn't work, what would we do? We would shade above the line inside the circle for our solution set. So again, get you some boundaries, graph your related equations, and test it. You can find your solution set easily.